So in this video, we're going to look at actually starting the energy pathways model. In the last video, we had just made a new scenario that we wanted to explore. So I'm going to come over here, and first step is I'm going to refresh the runs that I have. This test scenario 2 is the one that we just made. You can select any of the scenarios here and queue this selected scenario, and this gives you your list of cases that you can run. So each one of these is a different set of sensitivities that we selected on the cases tab. You can see your queue selected or queue scenario name up here. That's going to be updated. And then we have a series of kind of cases run controls. So this is our list. If I hit start runs, it's going to run all of these scenarios. One thing I can do is if I only want to run a subset of these, say I just want to run the fast bus electrification scenario that we made or case that we just made in the last video, I could actually take these, just delete them from the interface, and then if I hit start runs, it's only going to start that one case. Otherwise, it's going to start all the cases. I'll just queue this again to get our list back. This command window count is going to help control how many of these we run in parallel with one another, and how many are going to need to run in series. So if I have a command window count of 4 and I have 12 scenarios in total, that means I'm going to start 4 command windows, where in each window I'm going to have 3 that run together in series. And this is the options that you choose for here, and also for parallel processing subsectors within these cases will depend on the resources that you have at on your computer. Down here we have a load demand, export results, and save model Boolean options. So when you run the energy pathways model, if save model is true, then it's going to take that Python object, which is the kind of whole energy pathways model with all the subsectors, and it's going to pickle that to disk. And this can be a really large pickle. So by default, it's nice to actually sometimes keep this false, but it can be helpful for interrogating that kind of model in more detail after a run. It could be a helpful debugging tool. And so you can set that to true. If you've saved a model, you can also load a model here. So if this load model is true, then it's going to try to load a previously run pickled model. And then, in some cases, you can re-export the results there. And so if you went back, if you changed something in the code, you could re-export results from a loaded pickle. But most of the time that stays false, and then generally we do want to export the results, so that stays true. Here, check shapes. So this is looking at whether or not the electricity profiles have been pre-processed for the scenario. So if check shapes is true, that means it's going to read all the shapes from the database, check to make sure that those shapes have already been pre-processed in the right ways, and then cache those processed shapes for use later in that model run. Sometimes that process of just reading all the shapes from the database and checking to see whether or not the shapes are up to date can itself take some time. So if you are 100% sure that your shapes are good, you can also turn this to false. And then finally, the parallel processing here, a number of cores. This is for running multiple subsectors in parallel. So if you turn this to true, then for each one of the command windows, as it's running through the cases, it will run 3 subsectors in parallel with one another. Finally, this information down here, both the Rio config and over here looking at the optimized and flexible load, these are all things that relate to the capacity expansion model Rio. And And for users of just the energy pathways model, you probably won't need to pay attention to these sections. The last piece here are our active subsectors. So this is a list of subsectors that has been populated from the database. The is active column here is important for specifying whether or not you want to run a particular subsector. You can see here for this scenario in Australia, you can see there are a couple subsectors we have false, and these are actually false because at some point in the project, we took these subsectors and moved them to the supply side and off of the demand side, and therefore we want to make those false, and don't want to run them with everything else here on the demand side. But this also can be a helpful tool where if I want to just run some particular subsector in the model, say I'm iterating on that one piece of the model, and I want the whole thing to run faster. I can, basically make everything false, and I can just turn on the one subsector that I want to run. So, I care about residential pools. I've been iterating there with the data. I can just make that true. I can come back and I can start my runs. And now it's just going to be residential pools that get run. But let me refresh this. So I'm going to queue the selected scenarios. So after I've selected all these options the way I want to, then I hit the start runs button, and this will actually start the energy pathways model. So these models are, or command prompts are popping up on my other screen, but you can see this is now starting to run the model. I'm going to close these out, and then one final button here to highlight, which is the compile finish cases. When these 12 cases have all finished running, the model looks for this, and when they're all finished, it will actually create a set of concatenated CSVs that have results from all the cases. If you've only run, say, a subset of these, say you've run 6 of them and you haven't run the last 6, you can still compile just those cases that have finished by pressing the compile finish cases button, in which case it'll just compile what has finished, and then you can go ahead and kind of look at those results and use them.